Innotribe. Please welcome founder and CEO of Intersect, Mr. Jay Van Zyl.
Welcome back, everybody. You've heard a lot about what machines can do, artificial intelligence. You've seen a lot of theoretical constructs. You've heard a lot of discussions. And I think the next step is to think about what these things mean in a practical sense. And I think Suresh has been dealing with this for a while now, and we're making these things work for us. So I would like to hand over to him to give us insight into this.
Thank you. Thank you very much. It's an awesome room, actually. It's quite scary to be here. I almost thought I had to do a dance when the first beat came in. So what we have here, I had the fortune and small misfortune of buying a bank 6 years ago. And then I started to think that I could fix everything with a few APIs. And 6 years later, this is what I have. Each thing was incremental. So we have a legacy core system that is untouched because we tried every way to fix it. We just couldn't. So we decided to build everything on top of that. So we first built a smart account. We built an online banking, and regulators started calling me saying, where is your risk management? How do you know what's going on? So today I'm going to walk you through all these modules, and it turns out risk management is a very integral part of everything we do, whether it's online banking or whether it's debit cards, whether it is wires, ACH. So I'm going to start with one of our products. It's called OneCard. You can log in. We'll find out how much money I have today. We've been using it for demo quite a bit. So as we log in, there is a risk score being generated back in one of these systems today. And I do have multiple cards. I don't really have much money. Looks like I've done a lot of demos. $25 is not enough. So, but what it does is, this is a unique system. We had to build a real-time money movement system in the US. We can send money in real time in the US from one bank to another, from our bank to any other bank. We integrated into all the debit card networks, and we can push money in real time. So I'm going to do that today. But as I was building that system, I got a call from our primary regulator who said, nobody else is building a real-time system. Can you show me your real-time risk management system? As it happens, we would like to see a risk score. So we ended up building one. So what I'm doing right now is I'm actually sending $1 to Randy. When I hit send, it's going to call one of these systems before it lets the money go through. So that's what we're going to talk about today. And I have actually sent him $1, and he's gotten so many of these dollars from me. He should be rich by now. And my bank balance is coming down. So for a bank to be able to do real-time payments, it's like if you have a really fast car, you need good brakes, or you'll drive it only once. So we had to go back and build the Yantra risk scoring system along with the velocity management, which was, again, unique. We went to all the major networks in the US and said, we're a bank. We know how much money we have across all our accounts. Could you give us a switch that will stop the transactions once it hits a certain velocity? They were all nice. They smiled at me and said, there's no such thing. We can't do it. I said, it's not that hard, right? You just count the amount of money going out, and you stop it when it crosses the limit. They said, no, we can't do it. So we had to build that as well. So what I'm going to show you today is what's happening behind the scenes. And you see what we call as a Sigma dashboard. What that means is every transaction, as it happens, is measured against its own average standard deviation and across a bunch of other parameters. And to make it easy to understand, we plotted on that. So you can actually go in, select a transaction, click, and you'll actually see the transaction behind it. You can not only see the transaction, if I want to know where Doug Blacks lives or which company he works for, that's not hard to do as well. I can go in and see that's where the building is. Okay. So in essence, it's a system that allows a bank to create a risk score in real time, to manage the watch lists. All these things, by the way, I don't know how many of you are bankers here, but I'm an unpaid government informant with personal criminal liability. Right? If you're a banker, that's what you are. If you're a non-banker, you can sell software to bankers to get rid of the liability. But So it's something we have to do. Every transaction has to be risk scored. Every transaction has to be checked against all the people that the government says you should not do business with, and let them know if you end up doing. You have to come up with reasonableness. I don't know how many bankers are here, but you have to make a reasonable judgment on the validity of the transaction before you let it go. That's why many banks don't like real-time systems, because they can't make the reasonable judgment in real time. And we have built something that can help us do some of that. So what else can we do with these things? We not only check for standard deviations, we check for ages, we check for cumulative limits, we check for velocity, we even check the IP addresses. We do some crazy things with the IP address to be sure that things are not going haywire. So some of the things I want to talk about today is, let us say we pick one of these customers here, we pick Doug. We want to know more about Doug. We actually calculate a statistical model on each of the customers. We know how much money they got in, how much went out, who they're sending money to, who they're receiving money from. We can go further. We can get all their transactions. We can map it. We can see who's sending money to who, how those patterns look like. You can go into a particular transaction, see what's going on as well. So what else can we do with these things? Besides the watch list, which is something I have to do, we then came up with a rule engine. Well, we don't call it a rule engine, but for the sake of simplicity, we'll call it rules here. And I'll show you what can we do with a rule engine or rule list here. We can pick any field anywhere in the system. And then we can create a scenario around it. What happens if somebody uses this operating system, this MAC address, this IP address at this time of the day, and with so many miles away from their house, and if they send so many dollars to somebody else in this country, please let me know. Please risk code it in a way that we can stop the transaction or we can put it on a watch list. If that is not enough, if you don't think that enough rules, single rule doesn't do, we have something called compound rules. We can take a whole bunch of rules, and you can combine them, mix and match them, and then once you combine them, you can create a different name for it and a different set of risk scores for it, and then you can have that watched. And we have three things we can do with every rule. We can intercept a transaction and stop it if it crosses a certain threshold. We can watch it, or we can put it in nice colors in a graph to see and keep watching it after that. So the next thing I want to show you that we can do, and I think I showed you the maps already, for some of the bankers here, and I remember I was presenting this a while ago, somebody said, how do you do watch lists? We do all kinds of fuzzy logic on matching names to make sure that your name is not spelled in 3 different ways, so you get through the watch list. So we do all of those things. We do something called fields report, and this is something a lot of fun. We can tell you the amount of dollars going in and out via IP addresses. So in the future, every device is going to have some kind of IP address. It's going to identify itself when it comes to the bank. It's going through online banking, mobile banking. So we now have started tracking IP addresses in the bank. So we can give you statistics on, hey, this IP address did so much volume of transactions or debit or credit. So for some reason, if somebody else also uses the same IP address, we start to get a little more interested in those people. And especially in online account opening, by the way, use this for account opening. If on a given day, there are 3 or 4 different accounts being opened from the same IP address, we have a lot of interest in those people. We let them open the account, and they let inform some people with 3-letter agencies to go have a chat with them. And we see that a lot. I don't know how many of you know our bank is also the bank behind Movin, which is one of those tap and pay things. So we see a lot of account opening fraud. Sometimes we let them open the account. Sometimes we even let them transact to see where they're going, what they're doing. So it's a lot of fun for us. Once you have a system like this, you actually let them do stuff. It makes a better case when they're in court. And I'll give an example. We actually had somebody withdraw from an ATM, basically use a fake Experian ID, open account, and then withdraw from an ATM. So we found the ATM. We were all excited. That ATM did not have a camera. So we kind of found where the ATM was. It was in a police station in a court and police station. So there was no camera. So we called the cops. They said, no, we don't need a camera. It's a police station. So we didn't know who this was. We looked at the docket. He was being arraigned that day. He'd been indicted. He was in cuffs. They let him off for a minute. He went to the ATM, withdraw some cash. he figured he's already in jail, so what the hell, one more crime, right? So IP addresses become really, really important to track for us. We also track email addresses. Obviously, if people use similar domains, we track that. We track phone numbers. Becomes very useful if people try to use more than one number. And there are some other interesting things we do with phone numbers. I mean, I hate to put this way, but it's not like a movie. It's not like where you see in a movie. We actually know through telcos, in many cases, we know where you're standing, by the way the phone is. We don't need a mobile app. And we actually verify with the telco the address you've given to the telco to be sure that's the same address you're giving to us. And in many cases, we also know in the US how long you've been with the telco, or if you just bought the phone in a Walmart. So all these things happen behind the scenes. So one of the things we realized as we do all this is we just don't have a risk management system. We have an analytics system. We can actually now start to think about marketing to people. If you go back to the Sigma charts that I was showing earlier, oh, by the way, this is something else we found. We found that certain people receive a lot of money from lots of different people in the bank. And we also found certain people not in our bank receive money from many different people in our bank. That was a nice thing to track. And we then generally make a phone call to know more about these people. And I'm sure many bankers here are smiling already because that's another way of saying there's a lot of structuring going on in the business. So what has happened for us as a bank, as we evolved through all these systems, the transaction I just did went from the smart account, from the online banking to a smart account, went to the real-time payment switch to send the money. But before it could send the money, it went to Velocity, then went to the YRMS, make sure everything was fine, and then went there and said, now send the money out. All these things happened in those milliseconds when I hit the button to send the money. And we track all of those, and every transaction, whether you open an account, whether you're online banking, login, whether you're just browsing, doing nothing, every one of these things are logged. We are now building a profile on you. So please come to our bank, and we'll build a profile on you as well. And that's the only way I can keep the regulators off my back. Because when they come to my bank, we basically take them into a room and say, OK, there you go, go at it. We have 250 million records. If you want to search for anything, go for it, find it. Everything is risk scored. And we're complying with FFIC guidelines. So that's really our bank. That's where we've evolved to. That's what this particular piece does now for us. And this actually helps me sleep at night because I'm also the compliance officer. I'm also the BSA officer. I'm also the IT officer of the bank. So when the exam comes, I do need to be able to sleep at night and answer all these questions fairly easily. So with that, I'll conclude. I think I'm almost out of time. I'd like to leave some time for the next speaker as well. So thank you very much.
Thank you, Suresh. That was great. Thank you. I think it's always inspirational to see how people get these things right. Yeah. I would like to get some feedback from Bipin, who's based in the Valley at the moment, San Francisco, works with Wells Fargo as a head of innovation in one area of the bank, just to give us some comments on some of this. It's all right. Yeah. It's right there.
You me?
Can you
okay.
Yeah.
So, I've met Suresh a few times. Suresh runs a bank and a technology company. So the best thing, what I see in this, what he just showcased, is the real-time use of data. And you may call it risk and scoring system, whatever you may call it. From my perspective, it's about data, which plays the biggest role. And we as bankers, right, most of us in the room have used data for many things in the past, right? Like you've used it for cross-sell, fraud analytics. I think it goes beyond that. So one example which Suresh showcased, how you validate and you go through all the compliance checks. Another aspect which we personally feel is credit. You see a lot of disruptions which are happening in the industry in the credit space, right, lending space. And what has happened there is it's experience and data which has played a big role in creating those disruptions. So if you deploy some of the same capabilities in the banks where, and most banks are looking at it and most banks are partnering with companies like that to add more value to their ecosystem. So, this is like, a sci-fi movie. I can track you. I can see everything. And Suresh is like James Bond, I would say. He's been playing with a lot of technologies which really add value. I mean, at the end of the day, it's about data for banks, and how can we get value out of this data is the most important thing, I would say.
Vipin, thank you.
Thank you.
I think you're using it positively. It's not just James Bond all the time.
Well, he is like James Bond.
Thank you.
I would like to introduce Luke from NG Data to do this. Thank you.
Hello. Good afternoon, everybody. So I'm Luke from NG Data, and I wanted just to give an example of what you could do if you could take the things that we just saw maybe to a next level. And we talked about using data for marketing and using data for all kinds of customer experiences. And that's like basically what NG Data is doing. The company has half the age of the previous one, and we're sort of in what people say in next generation analytics, big data, machine learning, if you will. Now, we do what we do because the world of a bank is kind of evolving towards a different kind of ecosystem. So if you would make this graph of what a consumer does today, like most of the people would also draw a bank in this circle. But actually, that's not the case anymore. So the banking services will be embedded in most of these services that you would buy a house, you would buy a car, even go to a grocery store and all those kind of things. Think about how you consume media today. It's been statistically already proven that sites of CNN and Financial Times are only 10% accessed directly, 90% it's indirect. So you read the news indirect via other services that you get of what those companies provide. And that's exactly the same what's going to happen with the bank. So it's going to be about having these services available and all the things that you do as a consumer. But that means a lot of things. That means the services are embedded, but most of all that they are becoming all real-time and all on an individual level. And that the last step is actually that the decisions, because real-time means that decisions have to be taken by the computers and not by a human being that analyzes data and looks at graphs and then makes a decision. So that's why as a bank, you will have to know everything about the customer on an individual level. And not just that, it has to be an architecture that helps you supporting all these services that you have to develop. So your customer, we call it the customer DNA. It needs to be sort of the center of your entire architecture. It needs to be always current and needs to be real-time available and needs to be able to take actions, basically. And the customer DNA means a lot of things. So we've been working in these things with a lot of companies, with consulting companies. So how do you find a customer DNA? And it's a bit like a watch. Like the further you come closer to 12 o'clock, the more real-time the data gets, the more short-term you need the data. It goes from your social demographics, from your lifestyle, are you married, do you have kids, up to how responsive are you to certain campaigns that the bank does, what are current opportunities that you actually could be eligible for. But also it goes from what is the context that you do banking services. Do it on your phone, do it at work, at home. So what are your communications? What is the behavior? Are you on the site right now? So all information that actually doesn't mean anything 2 days later. So it is only valuable at the very moment that it happens, basically. So basically, that's what we do with NG Data. We developed a product that listens to all the interactions of a customer and immediately translates that into that DNA of a customer, basically. So let's have a brief look how it actually works. So please meet Mandy. So this is Mandy is a customer of the bank. She's on her phone doing things, and in the meantime, back at the bank, you will capture all the interactions. So that's what you see here, and in real time, it will actually update her DNA scores that are dependent on that specific interaction. So that was a mobile interaction. She can check her account. You will actually have updates of all the interactions that she does, and you see that. This example just starts from an empty DNA. We didn't know Mandy, so we're kind of building up with everything that she does, with every touch point that she has. So she would be on her account, but she would also be on the website looking for things, not necessarily buying things, but just surfing, scanning things. She has a mobile wallet. She has a lot of things. And steadily, you actually learn more, and you start building that DNA of Mandy. And it becomes really interesting when she starts purchasing things using her credit card. So that could be of all types of merchants. That can be online. It can be on a mobile phone, on a website. All things where, as a bank, you capture information. You have digital touch points. Also, the more traditional channels, we talked about ATM machines. Another thing is like when it happens, when she calls, so when she visits a branch. So all these things build up her DNA. But actually, that's not learning yet. That's just IT that is capable of running very fast and doing gazillions of interactions and processing that in real time. So the cool thing starts when you actually start building that DNA from the interactions, but then also monitoring in real time across like every second what Mandy does. And then you also, as a bank, take actions, you make decisions of doing things. And where you start actually learning is when you actually capture the feedback of what you do. So you would send out a sort of a campaign or a question to Mandy. How does he respond to that? And that, again, is an interaction that you learn from that, and then you will update your DNA of Mandy. So sort of in an automatic way, it will build a very accurate profile of Mandy just processing and updating itself on the data that you capture from that single person. Now, that's part one. So the DNA of Mandy evolves. It can start from scratch or start at a certain point, and it evolves to what she is really doing, not just on the long-term things, but also on the very short-term things. Now, that's just Mandy, but in a bank, you have like 50 million Mandys sometimes. So this happens for every single customer that you do. And what you can start doing that is actually layer on learning algorithms on top of that. So every single person has certain products at the bank. So you can start seeing people that are behaving the same way, that have a similar DNA, and learn from that. And that means that people that don't have a product yet, but they can have a very similar DNA of somebody that does have a product, so they might be very eligible for that type of product. Now, what you can also do, and there's many bankers here, so you know that you don't only have the banking products, but you also have the retail products that people buy, because you know it from the credit cards, you know it from the merchants. So you can actually also help merchants then facilitate their sales. And we talked about using data for marketing. And it can go, we go as far as determining actually the hobbies of people, the affinity. So we know that this person is loves fast food, he loves movies, we know all these kind of things. Now we say, why is this important? Well, there's going to be a day, and it's happening already now, where people will ask their bank, so I'm going to buy a house. What is actually a good region for me to buy a house? Because I want to know what kind of community I will be in. What are interesting schools for me? So the bank will have to help you and facilitate you in making those choices. And this will help you make those choices. Now, it becomes super cool when actually the system will also help you making decisions. And we talked about automated decisions and computers making decisions. Now, because you follow every customer and all these DNA metrics, which are around, on average in our projects, we have about 2,000 of those things. We all monitor everything, so the system can automatically alert you for certain opportunities or risks. There's an attrition risk, there's an opportunity for upsell. You can actually use that everywhere. And then you really become to what we call, as in big data, a data-driven company that actually looks at the data and lets the data make decisions for you. So here's Mandy again. So how does this actually work then? So Mandy is like surfing on her phone on websites for cars. So tomorrow her website will also be integrated with certain bank services. So she will select certain cars. She will see what insurances are available, what kind of loans could I take. She can access her bank services through the website of the car. But that means, in the meantime, the bank is actually building up all that information and building that DNA. So she is, at this period, pretty eligible for a car loan. So that means when Mandy, we talked about location services, so we have that information because every interaction is actually captured in a certain context, means location, means even time of the day. So when she shows up at a car dealership, the bank can actually say, well, we know you're interested in this, so we have a car loan here for you because we know you were looking for this type of car and this is already available for you. You just have to apply now and everything is done. So it becomes a real-time experience where a customer doesn't even talk to the bank anymore, but where the services are fully embedded. Now, what's the very important difference between traditional analytics and what you see now? So on the left side of this screen, you see basically how traditional analytics works. And most of the times, banks, they have great models, great analysts, but they're not using those like information sources that are closer to 12 o'clock. I mean, the behavior, the things that change very rapidly. So it means you have slow-moving models. And big data is, in principle, all about amplifying the weak signal, so the behavior of a person. If this person is looking for a loan now, then you have to react now, no matter what else you know about this person or what you do, what your marketing traditional models say. So by amplifying this with behavior, you will actually have much better results because you include the timing aspect of it. And this is a comparison that we made of what the targeting precision is in a traditional sort of customer interaction and what it is when you have include a real-time individual, all that behavior. So on the left side, you see 5% targeting precision, and marketing people will say, well, that's not too bad. But in the end, it's all about relevancy. That means this 5%, it's not too bad, but that means also that 95% of the people that received that information for you, they thought it was not relevant. And that's actually very bad. So you have a pretty long way to go there. And when you look, when you interact with an individual, we see that we hit like over 13 times better targeting. So the relevancy is definitely much better. And that means also that translates immediately into results, because a happy customer that has a good experience will automatically be much more loyal. And if you think about services in the future that you can have to do, you will have it in all kinds of things, from customer acquisition through upselling, through even advertising that a bank could do on a personal level, on an app or what have you, but also in finding risk and churn and attrition and everything. So I just wanted to conclude this sort of very small demo with kind of the three, I think, most important observations is that having data in real time on atomic level makes a huge difference, and then also being able to apply it. Somebody at Google said, like, data is 10 times more powerful than any algorithm that you can develop, and it's actually true. You don't have to simulate the reality if you can just look at the reality and have that taken actions. And also, the world is becoming, for a bank, very omni-channel. So that means it's not just your own email and website and everything, but it's probably the 50 applications you will have to integrate with. And therefore you need that individual information, because the other application will have to connect with you and ask information about the individual, of course. Maybe one last thing, because we talk about customer DNA, and I don't know if there's people of HSBC here, but I was in London the other day in the airport, and there was one huge ad of HSBC saying, like, your data is your DNA, or your DNA is your data, or something. So I'm happy that we're not the only ones talking about customer DNA. Thank you.
Look, that was great.
Thank you.
It's really showing that you can do something with this practically. So it's, Bipin, can I ask you again just to comment on this? Because we spoke about data a little bit earlier, and this could be worthwhile. Maybe just see if there's maybe a question or something. You wired?
Hello?
There we go.
Okay. So, again, I've known Luke for like maybe 3 years now, Luke?
Yeah.
Yeah, so we were one of the first financial services customer who actually started using these technologies as part of our research and development group. So Luke talked about a little bit about customer DNA, and from what we have seen, it's about understanding the customer from all angles. What I mean by that is customers interact through web, mobile, customer service call. Hopefully they're less. But the key thing is to understand the behavior, what tools they use, what products they use. And I think that that's given us a pretty awesome insight. That was like one of the use cases. Second use case, which we actually practically worked on it, and I was one of the users of that, where they were tracking on how I was using my Wells Fargo credit cards or my payments. And based on my profile, and my profile would generate a real-time score. So I had a score. And every time I changed, and actually we brought in data from social channels, a little bit from Twitter, Facebook, and location. So I think the whole idea and the concept for us using that technology was based on relevancy. I'm Bipin, I play golf over weekends, and here's my shopping pattern. Point being, we could then predict my pattern. And I know Luke touched a little bit about algorithms. We actually deployed two models there, collaborative filtering and knowledge-based filtering. Collaborative was much at a larger scale, like people. So if somebody who has a similar score to me. But once you go deeper into the algorithmic model where you're talking about knowledge filtering, that gives you a proper insight of the user, me as Bipin, who is Bipin, and what does it mean by him. So we've done a few pieces. We're actually going to expose some of their capabilities to our customers, where we are looking at leveraging their platform to match data and map data when customers are leveraging us as a merchant service provider. So thank you very much again.
Thank you, Bipin. Great. Thank you, Luke. That was excellent. Thanks so much. I would like to hand over to Julia now, who's going to give us a slightly different view on this whole implementation of analytics.
Thank you. Hi, everybody. So it's my pleasure today to introduce you to Pepper. So that's one of the first times for Pepper to be outside of Japan. But Pepper, for those who don't know Pepper, it's by no means a prototype. There are 5,000 Pepper today in Japan, serving in customer-facing environments, may it be retail, banking branches. So I'm not going to talk about artificial intelligence very long-term, although we do these kind of things. I'm not going to talk about long-term things, but about what's going on with robots today and how we use them for collecting data. So, by the way, Pepper, what are you doing here?
Hey, Julian. Well, we are supposed to talk about analytics here, aren't we?
Well, what can you do for analytics, Pepper?
I am not just a robot. I am a humanoid and also an emotional robot.
Oh, I see. So what?
Well, people feel like talking to me because I can move and express myself like humans. But above all, I can understand their emotions.
Really? You
Well,
can
look at my
understand my
tablet
emotions?
here. It shows when you are smiling or not.
So let's see that. Oh, I see. Here, oh, I see my face. Oh, you can notice when I have a happy face or a sad face. No, it's sad. I have bad words. You're a mean robot. And the curve. Oh, I see the satisfaction curve is going down, so my mood is bad. But if I have a happy face, if I'm touching you gently, if I'm telling you you're a good robot, I like you. So you see, actually, Pepper knows my mood. And that's very powerful. But what can it do for our business, Pepper? Take your time, Pepper. He's got his mood too.
Well, maybe if I tell you about everything about all the data that the other Pepper gathered at the entrance, it would seem more valuable. Look at that.
Let's see. What do you have for us, Pepper? I'm sure you're going to show us sometime soon. Yeah, there we go. So, that's interesting. That's actually the data that the other Pepper at the entrance collected. And that's where it gets powerful, because for every interaction that the other Pepper had at the entrance, that Pepper collected the mood. So we see that 63% of the people were very happy to attend this session. That's good. We have the age, the chart of ages. We know about gender. So we have 31% of female who actually talk to Pepper. And we have, and Pepper was, you were asking a stupid question, Pepper, that was about cheese.
So yeah, we see that very often people like cheese, actually. That's very far from banking, but what is that question, Pepper? Why cheese?
Oh, I can't hide my origins.
Yeah, you're a French robot, right? Okay. So this was a couple of examples, well, an illustration of what Pepper can do in real life here among us. So now let me give you a little bit of background about what happens and how we do that. So yeah, let me compare Pepper and what happens in the real world with Pepper to the web. If you go on Amazon, for instance, they know everything about you. When you log in, they know your purchasing history. Or if you compare that to a banking website, well, when customers log in, you know everything about them. But you don't know that when you go to a physical branch. So any people who has to attend customers there doesn't have the same level of information. Same thing goes for the product database. The person on the store, in the store, or in the retail bank are not fully connected, so they don't have access to the full range of products. And Pepper can do that. Pepper, through this interaction, can collect many data, just like on Amazon. And it goes beyond that, because you actually collect the full comments of people. And then you can analyze that. You add contextual information. You add their mood, so you can tell if people are really satisfied or not. And then you collect additional statistics. But why does that happen? That happens because people feel like talking to humanoid robots. That's really what makes a difference with a screen, maybe a very sophisticated touch screen or your mobile phone. You don't engage into the same kind of conversation, right? Pepper comes to you. Pepper is engaging. So how do we create situations where people engage with Pepper? Well, one very typical use case is just product recommendation, right? Pepper is connected, so it has access to customers' history, and here I give examples of retail products, but that can be any financial product, right? So Pepper asks questions. Pepper has many sensors, so Pepper can know your age, gender, mood, and many other things, your gesture. We do a lot of analytics on that. And of course, it's connected to your purchasing history. So based on that, you can really recommend the right product for the right people. Just like on Amazon, right? You always see the products that are good for you on the side of the banner. So other typical services that we can have with Pepper. Well, of course, you can direct people to the right counter, right? And that's a use case that we have implemented with Mitsubishi Bank, actually, in Japan. People get in, they are checking in, and the people at the counter, after Pepper asks the question, they know immediately why the people came for. So we're taking advantage of the waiting time to collect a lot of information before the real people actually get into interaction with the customers. And that's where we have a really complementary interaction. Pepper is kind of doing the repetitive task. It's doing what humans are bad at, doing repetitive things, and they don't want to do that. Once a human intervenes, that's really to go straight to the point. And of course, Pepper can answer many questions. And this is the other approach developed at Miso and Mitsubishi Bank and other banks in Japan as well. So you have typically two channels, right? You can touch people at your branches, and you can touch them via the web or on their mobile. Those are the two existing channels. And now Pepper makes a third channel, right? It's probably not as interactive as a relationship with a human, but it's much more engaging than a relationship with a mobile or with a screen. And that's really what makes a difference at the branches. And here we have this example at Mitsubishi Bank. Actually, the robot is able to talk any language. So in terms of attending people, you can receive people from any country, and Pepper can switch. Here we have an example with Now, which is another robot that we're doing. But that principle of the robot doing the things that the human cannot do properly or don't want to do is really the key principle. We're not replacing humans here. We're adding new capabilities. And that's what we're doing. The key thing is that we're building social robots, and that's the key to interact with people, collect data, and make use of it. Thank you.
I think that sometimes when I go to a branch and I speak to those robots,
Yeah, sure.
I think they call themselves humans sometimes.
Well, that's the key thing. You don't have to be too close to a human, otherwise that's scary for people.
Yeah.
So they have to be robots. They are robots. We're not pretending they're humans. We're not taking anybody's job. They should remain robots.
I was going to ask you about the thing around self-similarity, because I think in movies popularize the self-similar robots, but in actual fact, there's different views on that.
Yeah, there's a lot of theory around that. It's called the uncanny valley. If you're too close from a human being, actually, that's bringing out people. So
And the rules of robotics are there.
they are there. Yeah, when you look at Pepper, right, you can't be scared with robots.
Sorry,
If we refer to the previous session, I mean, are they going to take our jobs? Well, come on, that's a robot. I'm
People
talking
should have
about
told me that I
physical
was
robot.
standing in front of him, so it's rude, isn't it?
So now it's following your face and.
Okay. Bipin, you want to give some comments? I think this is a different angle.
So I think so. Pepper has been a center of attraction at Sibos in my mind. I don't know if you guys feel the same or not. A lot of people were taking photographs, but again, the point again is data, right? And computer vision. That plays a little bit of a role in what Pepper is really doing. And you mentioned about mood. That's again dependent on a few more data elements. In my mind, it's weather defines the mood also. And what has happened before you got to the mall or to the branch. So there's a lot of factors and data which kind of again aggregated and combined together. It could be very valuable in kind of interacting with the interaction between Pepper and a customer walking into a branch. Now, on a web and a mobile front, right, we've all used tools like Siri, Iris, Cortana. That's the first phase of your virtual personal assistant, so to say. And that's where, again, we personally believe that data plays a very big role, and my interaction models are going to change. I mean, Pepper is an awesome example from an interaction model. That's you're interacting with a robot, right? But then there is virtual personal assistants where if I want to set up a meeting with Luke, my assistant, virtual personal assistant, can interface with Luke's personal assistant, right? So I don't have to really talk to a person to set up a meeting. I think those are the things which are going to evolve over time. Experiences are going to change, and more data plays a role. And again, it's not just touch, it could be multimodal interaction, right? From a web, touch, speak, and there are situational moments where you cannot speak, so you can actually leverage the typing of a keyboard, and then there is that interaction. So artificial intelligence, fuzzy logic as people sometimes call it, computer vision, if you look at some of these areas, in some sense bundled with a lot of valuable, insightful data, right, and a good experience, what you see here is very powerful for the future. This is awesome, by the way.
Thank you.
Yeah. Thank you, Luke. So, what we're going to do now is wrap up this session and take a break. And I'm sure that you guys want to have a conversation at some point with robots. And I think that artificial intelligence, as the theme of today, has really raised various different dimensions. And I think that analytics as the undertone has definitely showed something that is very, very interesting, and especially in the context of the banking world. So thank you for attending, and we can take a break now. Thanks. Thank you.